Hello everyone, and welcome to the fourth episode where I continue to tackle the You Shall Not Pass map on the Captain difficulty. If you have followed my journey from the start, you have seen that I have already established a strong industrial base. For here on the left, I have set up the production lines for basic construction materials spanning tiers 1, 2, 3. To the right on that raised section, I have my maintenance area, a spot for crafting tier 2 vehicles, a glassmaking station, some laboratories for tier 2 research, and a recycling center. And over at the left mountain, that's where I manage food production. There I'm growing potatoes, corn, vegetables, and also produce bread and tofu. For power, I have placed a power plant and tree farm near the top coal patch. To ensure clean water, I positioned a facility between my main base and the sea. Additionally, I have set up an oil refinery just to the right of my starting point. And the sand extraction, well, I have chosen a spot right at the edge of the sandy beach, with this very long conveyor to deliver the sand. As I highlighted in the last episode, my upcoming goal was to construct a big permanent oil refinery, complete with all its associated production chains. Once operational, this refinery would be the heart of my colony's supply chain, producing essentials like diesel, rubber, plastic, fuel gas, hydrogen, fertilizer, sulfur, and ammonia. The primary challenge that delayed this endeavor was the absence of an appropriate docking area for oil delivery. However, for your convenience, I will bypass the wait and directly showcase some critical moments which have transpired during this period. As you can see on the right, I've still been using irrigated farms. However, with my existing glass production already in place, I deemed it appropriate to transition these farms to greenhouses. So greenhouses, they offer a 25% increase in food output and consume an additional 12.5% of water and fertility. So this makes them a more efficient choice compared to traditional open farms in the long term. As you can see, I have moved ahead quite a bit already in time. The ramp for the oil harbor has been progressing well. The materials for this came mostly from the digging of two other ramps. One was located between the copper and iron deposits, and the second one was located to the right from the housing area. During this extended waiting period, I also made another significant upgrade, the Tier 2 smelting facilities. So for Tier 2 smelting of copper and iron, crushed ores and coals are needed, with sand added for copper and limestone for iron. In general, Tier 2 smelting operates at double speed of Tier 1, using ore and coal more efficiently. However, this comes with the need for extra ingredients in a slightly more intricate logistics process. To aid in the copper smelting, I set up several crushers, and for the time being, sand was transported in by trucks. I repeated the same for iron smelters, and limestone again was delivered by trucks. After waiting for additional half an hour, the platform for the oil cargo docks was finally almost complete, and I proceeded to build on it. But before I could begin planning the chemical factory, another pressing issue emerged. I was nearly out of coal from the first deposit. To address this, I constructed a new cargo dock and set it up to accept coal shipments from offshore mines. The crater remaining from the old coal deposit was subsequently filled and leveled, allowing me to utilize this space for future construction. By this time, the ramp on the right was also complete. I quickly established here two fruit farms to enhance unity production from my settlement and to reduce the pressure on the current food production facilities. After completing this task, I finally turned my attention back to the chemical factory. Firstly, I constructed 3 pipes connecting to the oil harbor. One pipe was designated for transporting raw oil, the second carried diesel to refuel the cargo ship, and the third carried seawater, essential for production of chlorine, a key component in plastic synthesis. Next, I delved into designing the factory layout. I estimated that 4 rows of refineries with a consumption rate of 216 crude oil per minute would suffice for my needs until the very late game, until I launched the rocket. So I divided these 4 rows into 2 sets, with each set powered by its own gas boiler. A critical component of any oil refinery is the water stripping process. First and foremost, this process yields sulfur, which is vital for the production of rubber and plastics. Additionally, it generates ammonia, needed for creation of fertilizer and hydrogen. Another benefit of implementing sour water stripping is the significant reduction in the overall water consumption of the entire setup. For my configuration of 4 sets of oil refineries, I required 3 strippers. The lightest oil fraction produced from the third refinery stage is naphtha. So I have established a balancer that prioritizes directing naphtha to the plastics and rubber production over on the right. Any surplus naphtha is channeled to the cracking units where it's transformed into fuel gas. Another small puzzle which I needed to solve was determining how to handle the heavy oil emerging from the first refinery stage. I had 3 options: burn it in the gas boiler, transform it into diesel fuel, or convert it into naphtha. I chose the latter, converting it into additional naphtha, as I believed my second refinery stages would already provide ample diesel production. The necessary hydrogen for heavy oil cracking came from the hydrogen reformer using fuel gas. Interestingly, this configuration doesn't demand a continuous fuel gas input. It only needed it to initiate the process. In fact, there was a slight surplus of the fuel gas if I redirected the fuel gas generated by the cracking unit back into the reformer. In summary, after completing oil pipe connections, here is the state of my oil refinery. It took in water, crude oil, and energy as inputs and yielded diesel, fuel gas, naphtha, sulfur, and ammonia as outputs. At this stage, finalizing the chemical production facilities atop of this oil refinery was just a routine task. I have built an array of rain collectors for water supply. Following that, I constructed 4 rubber factories, which in my estimation should meet the demand until the end game. I also established a basic chlorine production line. So it began with transforming seawater into brine using evaporators, and then processing the brine into chlorine gas with an electrolyzer. And this chlorine gas was the crucial component for producing of plastics, the last major element of this puzzle. Completing this chemical facility marked a significant milestone, enabling me to finally advance towards my ultimate objective, launching the rocket. At this point in the game, my settlement began experiencing severe cases of illness, drastically reducing the population each time they occurred. Unfortunately, I had everything needed to start the production of Tier 1 medical supplies. Components included ethanol, plastic, and steel. I produced ethanol from corn mesh temporarily, as I hadn't yet acquired sugarcane seeds. Plastic and steel were transported by trucks, and the produced medical supplies were then delivered to the settlement via a lengthy conveyor belt running alongside the ramp. Having established the medicine production, my focus shifted to the managing the waste generated by my settlement. So it was necessary first to expand the wastewater recycling and also figure out the solution for the expansion of general waste disposal. After evaluating different strategies, I settled on the following approach. I decided to incinerate the general waste and use a boiler for burning bio-waste. Both processes would generate high-pressure steam, which in turn I planned to use for desalinating seawater, producing both fresh water and brine. Fresh water was to be supplied to the settlement and used in the burners, whereas the brine would be used in generating chlorine for wastewater treatment and salt for glass mix production. The sludge resulting from the wastewater purification process was to be converted into compost and fuel gas, and this fuel gas would then be utilized in the incinerator, thereby completing the recycling loop. This construction turned out to be sustainable over time, yielding not only a surplus of fuel gas, but also some compost and brine as byproducts. One reason I'm so interested in this game is its capacity for intricate designs such as this, where everything is repurposed.
It's fascinating how even human waste can be transformed into valuable industrial materials.
So I hope you found this episode interesting. If it proved useful to even just one person, then I will know that my efforts have not been in vain. I wish you plenty of inspiration in designing your own factories, and I see you in the next episode. Bye bye!